So in the last video, we were here, saying that when the air resistance increases to a point that equals the weight, the object will fall with constant uniform resistance. Now the same thing happens when object falling in oil or water, but the difference is that the fluid friction in this media is larger. Okay, LAR is larger in this media, and it takes shorter time to reach the terminal velocity. With that we come to the next page. The next page is on the on the VT graph of an object falling in vacuum and in air. So let me capture this screen and paste it on this pane application. So for the left graph, when it falls in a vacuum, we've got that straight line, okay, and the slope is 10 meters per second squared, the slope. However, for an object falling in air with air resistance, okay, it will ultimately reach a terminal velocity. Let's make it a better straight line, okay. Ultimately, okay, and we call this terminal resistance. So, and we call this terminal velocity. Okay, and the VT graph goes like that. At first, it will accelerate at g, and then the acceleration is slow. Okay, it goes something like this. Okay, so this is the graph of falling in air with and without air resistance. Let's get back. Okay, now the air resistance actually depends on the surface area of the object, the mass, the shape of the object, the nature of the fluid, whether it is in air, in water, or in oil, etc., etc. That means for the same speed, air friction is larger if the surface area of the object is larger. So this is the key of a parachute. So let's look at skydiver. Now, actually, in reality, skydivers do not open the parachute at the very beginning, but they will do so after they have fallen for some distance. Now, the driver falls, and later on reaching a terminal velocity, which is high. And at this stage, the weight equals to the air resistance. When he opens the parachute, air resistance is larger. larger than the weight of the diver As a result, for example, in this diagram, the air resistance is 900, but the weight is only 500. As a result, the net force after opening the parachute will be upward. The net force will be upward. Hence, the diver decelerates. Hence, the diver decelerates. The diver decelerates and air resistance will decreases until it balances the weight again. So that is the last in this last diagram. Okay. He finally reached constant terminal speed, which is safer. Okay. So finally, let's look at the VT graph of Let's look at the VT graph of a sky diver. So let's look at it. So in the first stage, okay, let me put down two lines. Okay, one line and the other two and the other line, right? Okay. And we have V1, 2. So let's look at it. Yeah, at first it before the parachute open, it will reach terminal velocity without the parachute. After opening the parachute, it decelerates until it gets to the second terminal velocity. Okay, so let's put down, this is the t in second, and this is the v in meter per second. Okay, so this is the VT graph of a parachute.